Hi, welcome to 4.3 transform radical function. Um, if you guys don't know what a radical function graph is, it is basically in this form: f of x is equal to square root of x. Um, I'm sorry about the airplane noises. Apparently, I live near a military base, so there you go. So f of x equals square root of x. That's the functional. That's the radical function form, and the graph looks something like this, right? Looks something like this. Notice how it doesn't have a negative because you can't put a negative inside of a radical function. That will turn it imaginary, and we don't like that. I should talk about imaginary functions right after this in the rational function unit. So imaginary number time, because I'm just gonna do a whole lesson on that. It's not gonna be part of the book. So next we have square root of 2x. So I want you to see these two for a second. This is considered as a horizontal shrink. This is a horizontal shrink. So it's a horizontal shrink by 1/2. But this is a vertical stretch by 2. And if you take a function, okay, this will be a little higher, right, than this, and this will be pretty high. Oh god. There you go. Right? That looks disgusting, by the way. I'm gonna change that. But if you think about it, a horizontal shrink is like this. So you're pushing the graph in a little bit. But a vertical stretch is like this. So it's kind of the same thing in this case, because square root of 2x is square root of 2 times the square root of x, whereas this is 2 times the square root of x. So this is just a smaller vertical stretch than this, and this is a bigger horizontal shrink than this. This would be square root of 4x, not square root of 2x. So that's just something to keep in mind. We have 1/2 the square root of x, which is a vertical shrink, so it'll be even smaller. It'll be like something like this. That's a really bad graph, but it'll be something like that. Negative square root of x. Negative square root of x is all the values will be reversed. So if x is equal to 0, then y will be equal to 0. If x is equal to 1, y will be equal to negative 1. So it's a reflection on the y-axis. I really could just take the top graph and flip it 90 degrees, but I'm just going to draw it right there. That's the graph. Square root of negative x. Now I've said that in order for in order for the graph to not be imaginary, you have to have a negative number. You have to have a positive number in it. So in order to transform a negative inside graph into a positive number, you have to have domain that is a negative. So 0 would be 0, but our domain goes this way instead. So it's a transformation on this axis, on the y-axis instead of the x-axis. That's pretty interesting. And if you have negative square root of negative x, it will be at 180 degrees. Okay. Otherwise, you should already remember this. Square root of x plus 4 is same thing as the squared. X plus 4 is 4 units to the left. So we can just draw that right here. I'll be I don't know, the left right there. And then square root of x plus 4 is 4 units up. So it'll be a graph that looks like this. It'll look kind of dumb, but like that graph. Okay, next we're gonna write a described function. We're gonna write a described function. So this is let the graph um, of g be a horizontal shrink by 1/6, followed by translation to the units to the left of the graph of fx equals 3, the cube root of x, by rule for g. Now notice how the cube root of x has infinite domain and infinite range, because negative numbers can be in the cube root of x, and it wouldn't really affect the result. So it's an odd function, because if you take the negative inside and if you take the negative outside, it still flips the same way. But you guys don't need to know that. Let the graph of g be a horizontal shrink by a factor of 1/6. So since it's a horizontal shrink by a factor of 1/6, And horizontal shrinks mean that it's going in, so it's going in, the graph is going in, it's basically a vertical stretch. Horizontal shrinks are vertical stretches. So horizontal shrink by a factor of 1/6 is a vertical stretch by a factor of, in this case, it's the square root of 6. So it will be cube root of, wait, let me actually check what the, number is. It is 3 units to the right. 3 units to the right. So it will be 3 units to the right. Right, writing a described function. I'm sorry. There you go. So 3 units to the left. I mean to the left. So it will be. I'm gonna draw this graph. It will be the cube root of 6x because it's a horizontal shrink of 1/6 to a vertical stretch of square root of 6, cube root of 6, and translation of 3 to the left. So 3 to the left means it's got to be in here as well. Since it's 3 to the left, it's 1, 2, 3. So plus 3. Then it'll be 3 to the left right here, and it'll look something like this. It'll look something like this. It's a pretty wonky function, but it's a function. It's a function. And in fact, the 6 that's in here, the 6 that's in here will also affect the 3. So it'll look something more like this. And then it'll be cube root of 6x and then plus 18. So the 3 units to the left is also affected by the horizontal shrink, and that's why it's called a horizontal shrink. So you graph a written function. I'm going to graph a written function right now. So f of x equals cube root of x, g of x equal to cube root of negative 8x. Now since it's negative 8x is a reflection across the y-axis, since we don't want negatives inside of the thing. So we're gonna do this, and it's a negative 8x, so it's a horizontal shrink by 8. That is big. So it'll probably look something like this. It's a pretty big graph. Okay. Let me check. Yeah, it'll definitely look something like that. And since I think it's a cube root function, so it'll look something like this. A really big graph. There you go. Looks something like that. Right? Next, graphing an x equals y squared function. Now, there's a difference between. It's not a function. First of all, it's not a function. Okay, don't get me wrong on that. It's not a function. It's an equation. It's an x equals y squared equation because if you solve for y, you get plus or minus x, and plus or minus x is not a function. So we're gonna graph it. What's the function of square root of x? What's this? And what's the function of negative square root of x? It splits across the y-axis, so it's this. What's the function of both? It's just both combined. It's just this. Well, what's the equation of both? And this. So it's a parabola that's flipped 90 degrees. So we'll practice how to do 90-degree flip parabolas right now. 1/3 y, 1/3 y cubed, y squared. So you multiply by 3, right? Y squared is equal to 3x, and then you take the square root, y is equal to square root 3x plus minus. Do not forget that. Okay, and then I'll do this as well later. So plus minus cube root 3x. It won't look as flat as this, but it'll look pretty flat. So it'll be something like that, and then something like that. There you go. That'll be the graph. Okay, next is y plus 3 cubed minus 5 is equal to x plus 4. Oh god, that is a terrible graph. Okay, I'm really sorry. Y plus 3 cubed minus 5 equals x plus 4. So this is kind of dirty. It's kind of a dirty graph. So we'll clean it up. Plus 5 plus 5. Now you got x plus 9. And then take the square root, we got plus minus y plus 3 equals plus minus x plus 9, and then subtract 3 on both sides, and you'll get y equals plus minus x plus 9 minus 3. That is really ugly, I'm sorry. But minus 3 means it's 3 down, and then x plus 9 means it's 9 to the left. So that'll probably be like right there, and right, I'd say right there. So it'll be pretty flat. This is not pretty flat. This is pretty. There you go. It'll be something like that. That's the parabola. It'll start here, and then it'll be like that. Next, these are word problems. Okay. How do you see it? Does this graph represent a square root function or cube root function? Now I already told you this is the cube root function. It can hold negatives. It accepts negatives, but this function doesn't accept negatives. So it looks more like a square root function. And if you plug in the points, first of all, this graph is the domain of this graph is from negative 2 from negative 2 from negative 3 to infinity, right? And the range of this graph is from 1 to infinity, from 1 to infinity. There you go. That's the domain, and that's the range. The function's a square root function, and the graph is since it is 3 to the left, graph is 3 to the left, it will be square root of x plus 3, and then the graph is 1 up, so it will be plus 1. That's the graph. And if you plug in the points, you should get the same thing. Minus 3 plus 3 is 1. That's correct. Minus 3 plus 3 is 0. Plus 1 is 1. Minus 2 plus 3 is 1. Plus 1 is 2. So yes, you do get these points. Next, 68 mathematical connections. So the surface S of a right circular cone with slant height of 1 unit is given by this formula, where r is the radius of the cone. Use completing squares to show that this. Show this. So I'll do it. Pi r squared, pi r plus pi r squared is equal to S. Right? So we need to find r. In order to find r, we need to do completing square. Pi r plus pi r squared is pi times r plus r squared, right? Plus r squared. And in order to complete the square, we gotta half the middle and square it. Half the middle. What's the middle? It's 1/2. It's 1. So you half it. It's 1/2, and then you square it. 1/4. So add 1/4. And then since you're adding 1/4 inside, and it's multiplied by pi, you gotta subtract pi over 4. You gotta subtract pi over 4, and that's equal to S, right? So then you can do pi r plus 1/2 square minus 1/4 plus minus pi over 4 equals S. Add pi over 4 over to the S side, you get S plus pi over 4, right? So you add pi over 4 already. You divide it. You divide everything by pi, so you'll do over pi, right? And then you take the square root. So you get rid of the square root, and then you get rid of the square as well. Take the square root, and then subtract 1/2. That's the final step. Subtract 1/2. So this is the equation that you get. So we'll bring it back up right here. We'll take this. Oh god. Oh god. Oh god. I made a mess. So we'll take this. Right? S plus 1, S plus pi over 4, and we gotta get this. S plus pi over 4 over pi minus 1. So in order to get this out of here, we just take pi, square root of S plus pi over 4, we keep that in there, and then this is also taken into the square root formula, so we just do times 1, so 1 over pi plus S plus square root pi over 4, s plus pi over 4, and that's equal to 1 over square root pi times the square root of s plus pi over 4, and then add the minus 1 half in at the end. And that's how you get the formula. Next, graph the equation. We are not graphing any equations today. Find the radius of a right circular cone with slant height of 1 and the surface area of 343 pi over 4 square units. So the slant height is 1. If the slant height is 1, and this formula is for a slant height of 1 cone, we don't have to worry about modifying the formula at all. So we just have to put the surface area in here. So S is 3 pi over 4. So what's 3 pi over 4 plus 3 pi over 4 plus pi over 4 is 4 pi over 4. 4 pi over 4 is pi, just regular pi. 4 pi over 4, and that's just pi, right? We have 1 over square root of pi multiplied by the square root of pi minus 1 half. Anything multiplied by 1 over it's the same thing. Anything multiplied by its reciprocal is equal to 1. I'm pretty sure you learned that at a very young age. 1 minus 1 half. 1 minus 1 half is equal to 1 half. And 1 half is the radius. 1 half is the radius if the surface area is 3 pi over 4 square units. That's gonna be it for today's episode. Next episode will be on radical equations, solving radical equations. So